Okay, hello everyone. In this video, we are going to discuss Common PG Entrance Test 2023 or CPET 2023 Odisha. Question and answer. Subject is your physics. In this question booklet, total number of question was 80 and the time is 60 minutes or 1 hour. Here you can see there is no negative mark. Here there will be no negative mark for wrong answers. Okay, 80 questions 1 hour. So one by one we are going to discuss. Here, this is the first question. It is asked that if three particles each of mass m, suppose m, okay, are at points 1 2 3 2 3 4 and 3 4 5, then the center of mass of the system is where, is at where? Four options are given. So in general, x coordinate of center of mass is written as summation over mi xi by summation over mi. Y coordinate of the center of mass is written as summation over mi yi by sum of mi, and corresponding z coordinate will be written as mi summation over zi by total mass. Okay, so here three masses are given. So x component, if I am going to calculate, here each mass is m, so here m, and x1 here summation of x component, x coordinates 1 2 and 3, that means 1 plus 2 plus 3 divided by 3 masses, so 3m. Okay, so x component we found that 3 plus 2 5 plus 1 6, here m got cancelled, 6 by 3, that is your 2, that is your 2. X component of the center of mass we found 2. Likewise y component, if I am going to calculate, this will be equal to m taken common, y coordinates are 2 2 3 and 4, 2 plus 3 plus 4 by 3m. So here mm got cancelled and we can found 4 plus 3 7 plus 2 9 by 3 is your 3. Now calculate the z component, which will be equal to m taken as common, z components is your 3 4 5, 3 plus 4 plus 5 by 3m. mm got cancelled, so here 5 plus 3 9 plus 12, 12 by 3, that is your 4. So the center of mass, coordinate of center of mass is your 2 3 4. This will be the correct answer. Now we are going to go for the second question. In the second question, it is asked that if a particle is at rest, rest means velocity will be 0, right? Is in a rotating frame, rotating reference frame, the magnitude of Coriolis force acting on the particle is, here four options are given. See, in general, Coriolis force is written as minus 2m mass of the particle, velocity of the particle into angular velocity of rotating frame. This is the angular velocity of rotating frame, and this is the velocity of the particle. So here velocity given as 0, so Coriolis force will be 0. I suggest you just remember this expression, okay, for solving the other numericals. Next question, moment of inertia of a solid sphere about a tangent. Okay, so this is the solid sphere. About the tangent means about this one. About this one, what will be the moment of inertia? See, we know that moment of inertia about the diameter of a solid sphere is your 2 by 5 m r square. So here r is the, here small r, okay, r is the radius of the solid sphere. Now I am going to apply parallel axis theorem. So this distance also r, applying the parallel axis theorem, 2 by 5 m r square plus distance between these two axes, so it will be mass m into r square. So if I am going to add this one, I can get 7 by 5 AMR square. So C is the correct answer. Next, fourth question. The theoretical value of Poisson ratio lie between. It will lie between -1 to plus 0.5. That you have to remember. See here, in general, the Poisson ratio represented by sigma, which is nothing but your transverse strain by longitudinal strain. Okay, you just remember this one. Transverse strain by longitudinal strain is nothing but your Poisson ratio, and its theoretical value always lie between -1 to plus 0.5. Now we are going to move for the fifth question. Here in question number 5, it is asked that the depression at the middle of a light double cantilever supported at the ends and loaded at the middle is proportional to what? Four options are given. So loaded where? Loaded at middle. So this is the situation. Supported by two ends. So if load will be given at the middle, so depression will be at the middle, like this. So load will be given at here, suppose W. So it depressed from its original position this distance. Okay, so this is the depression. Let Y. So for this case, Y is equal to, if we are going to derive, it will be, yes, here is the, suppose this is the total length of the rod, or this rod total length is your L. Okay, so this depression will be weight LQ by 48 Young's modulus Y into Ig. Here Ig represents geometrical moment of inertia. Geometrical moment of inertia. Okay, here geometrical moment of inertia means, see, geometrical moment of inertia of this curve. Okay, so this is the curve. Its geometrical moment of inertia is your Ig. So here you can see Y is proportional to LQ and inverse is proportional to Young's modulus. For this question, the answer will be B, proportional to LQ. Somewhere you can found Y or depression is proportional to 1 by Young's modulus or 1 by Y square, Young's modulus square, Young's modulus, like this. So at that time this expression will be useful. You just remember for the light cantilever, double light cantilever. Okay, now we are going to move for the next question, question number 6. It is given that if the pressure inside two sub bubbles are 1.01 atmosphere pressure and another one is your 1.02 atmosphere pressure, then the ratio of their respective volumes are, here it is asked that ratio, but in the question, in your answer options, it is not given in the ratio format. You just consider this is your 2:1, 4:1, 8:1 and 16:1. So what will be the ratio? So here it is given that the two sub bubbles, suppose this is your first bubble, radius is your R1, second bubble radius is your R2, suppose this is your R2. So inside pressure for first bubble is given 1.01, for second 1.02 inside pressure. So what is the ratio of their volumes? Okay, here this is one of the important question. Okay, what we know, excess pressure, you just remember this expression, it is most important. Excess pressure inside a soap bubble represented as del P is equal to P inside pressure minus P outside pressure, which will be equal to 4T by R. Here T is the surface tension. Okay, T is the surface tension, R is the radius. This expression you just remember. Now excess pressure for bubble 1, if I am going to calculate, then P inside given as 1.01, outside always atmospheric pressure 1 is equal to 0.01 excess pressure for bubble 1. Likewise for bubble 2 excess pressure, if I am going to calculate, it will be 1.02 minus 1 is equal to 0.02. Now just take the ratio, that is del P1 by del P2. What I am going to get? Del P1 by del P2 if I am going to take, then this is nothing but your what? 0.01 by 0.02, which will be equal to, see, excess pressure formula is your 4T by R. So surface tension is constant for both the bubbles because the material is same. So if here I am going to write 4T by R1 by 4T by R2. Okay, so that implies what we can get over here. Here we can get R2 by R1. Here this one 40 got cancelled. This is nothing but R2 by R1. R2 by R1 we got 1 by 2, or you can write R1 by R2. R1 by R2 is nothing but 2:1. Okay, okay. Now we are going to go for ratio of their volumes. That means V1 by V2 we want to find out. V1 is nothing but 4 by 3 pi R1 cube by 4 by 3 pi R2 cube. So here we found R1 by R2 whole cube. So here R1 by R2 we found 2:1. So this will be 8:1. So the answer is your C. Okay, okay. Now we are going to go for question number 7. In your question number 7, it is given that if a planet moves around the sun in a elliptical orbit with a semi-major axis, this is a direct question. Okay, this is the direct question. Sun over here, Kepler's, this is the Kepler's law. So semi-major axis, semi-major axis is your this one. A it is given, and this is obviously semi-minor axis. So time period is proportional to what? This is the direct question. We know this is the Kepler's third law. So here this will be T time period square is proportional to A cube. So that implies time period is proportional to A to the power 3 by 2. So here A is the semi-major axis, so answer will be D. Okay. Now the next question, question number 8, it is given that which statement is true for central force problem. But here I am going to suggest to all of you that do not forget the first and second law also, Kepler's. This question is belongs to Kepler's third law. Okay, the first is your sun is earth is rotating in about the sun, where sun is in a elliptical orbit and sun is one of its foci. First law. Second law is belongs to aerial velocity. Aerial velocity is constant. Okay. Now question number 8, which statement is not true for central force problem? Central force is conservative. This is true. This is always true. Conservative. Angular momentum is also conservative because there is no torque. Torque is 0. That implies dl by dt equal to 0. That implies L is constant or conserved. Angular momentum is constant. Aerial velocity is constant always. Here I told that according to second law, this is one of the central force problem. Okay. So aerial velocity is constant. This is also true. Mechanical energy is not conserved. Actually, mechanical energy also conserved, but it is given that mechanical energy is not conserved. So this is the right option for this question. Okay. Now we are going to move for the next question. Question number 9. The magnitude of gravitational field or gravitational field intensity at the center of the solid sphere. So this is the your solid sphere. At the center it is asked what is the gravitational field intensity. In general, inside gravitational field intensity inside of a solid sphere is represented as G capital M by AQ into R. Okay, so here A is nothing but radius of this sphere, M is your mass, G you know universal gravitational constant. Here R is what is the distance from center to any point inside the solid sphere, R. So here R will be 0. Here R will be 0 because in the question it is asked that at the center. So here if I am going to consider this, then this distance will be 0. So therefore gravitational field intensity also will be 0. If I will put 0 over here, then answer will be 0. Question number 10. The time period for damped oscillator motion is what? Here B is the damping factor, M is the mass, K is the spring constant. The situation is like this. You can consider. This is a spring, mass is there. So if it will oscillate in the damping condition where K is the force spring constant and here M is the mass of the spring neglected, what will be the time period for damped oscillatory motion? We know that angular frequency for damped harmonic oscillation is nothing but omega equal to K by M minus B square by 4M square. Okay, we studied this one. You can check your book itself. So what is the meaning of K and B already given in the question? You just solve it. That means here angular frequency omega is given this one, nothing but 2 pi by T equal to this much. Okay, that implies T will be, just you solve it, you can find the answer this one. 2 pi M by K root over 1 minus B square by 4mk to the power minus 1 by 2. Option is C is the correct option for question number 10. Okay. Now we are going to go for our next question, question number 11. In question number 11, it is asked that for a conservative system, the generalized force is what? The options are: has necessarily the dimension of force, dimensionless, cannot have dimension of force, may have the dimension of torque. So here we can consider a conservative system, this one, particle moving in a circular path. Okay, this is a central force problem or a conservative system moving in a circular path. So here generalized displacement is your theta, angle is your generalized coordinate. Now the generalized force for this case will be the torque, which is nothing but R cross F. Okay, so here the D option will be correct. Now we are going to go for next question, question number 12. It is asked that the Hamilton's canonical equations are, it is a direct question. Here, this one. See, Q dot equal to del H by del Pk, Pk dot equal to minus del H by del Qk, and this one, del H by del T equal to minus del L by del T. So this is the answer. option number B. This is the direct question. Now question number 13. In question number 13, it is asked that if Lagrangian of a particle of mass m moving in a plane is this one, Lagrangian given, then we have to find out the momentum px along x-axis. See, in general, px is nothing but del L by del x dot. Now I am going to apply this one for this Lagrangian. That means differentiation with respect to x dot. Then first term will be mx dot plus second term x dot term is not there, so it will be 0. Third term also will be 0. Fourth term x dot term is not there, so it will be 0. In the fifth term x dot is there, so we can found minus y. So the answer will be C option, mx dot minus y. Okay, next question is your 14. They ask that velocity profile of liquid flowing through a narrow tube has which shape? See, for this case, suppose this is a narrow, the velocity profile will be like this. That means at edge the velocity is somewhat lesser and it is increases up to its center, then it is decreases like this. Okay, so it is like a parabola. The velocity profile is like a parabola, so answer will be the C option. Next question, question number 15. For momentum to be conserved, the Lagrangian is to be of form dash. Okay, so here you can see 4 options are given. We know the Lagrangian of a system is written as like this: d by dt of del L by del. Suppose if I am going to consider along x-axis, suppose this is your d by dt of del L by del x dot minus del L by del x equal to 0. Right. So here momentum will be conserved, and just now we discussed that px momentum px is nothing but del L by del x dot. That means here I can write d by dt of px, because this one is your px, momentum along x-axis, minus del L by del x equal to 0. So this part will be conserved. That means this part should be 0. How it will be possible? That means this term should be 0. So if del L by del x will be 0, then we can found d by dt of px will be equal to 0. That implies px will be a constant or conserved. Right. So the here condition should be del L by del x equal to 0. That means your Lagrangian is not to be function of generalized coordinate. So here, if I am going to consider option number A, Lagrangian is explicitly depend upon coordinate, generalized coordinate. So this option could not be accepted. This option also depends upon the coordinate, not to be accepted. This option not depends upon the coordinate, generalized coordinate. So this option will be accepted. Here you can see D, option number D also Lagrangian depends upon generalized coordinate. Here Q is there. So C will be the correct answer. Okay, now we are going to move for the next question. Here, this question belongs to relativity. If an electron is traveling with the velocity 0.98 c, the mass of the electron that appears to be stationary observer in lab, this is as the relativistic mass. So here, the rest mass let us consider m naught. So the relativistic mass simply is nothing but gamma factor multiplied with rest mass. Gamma factor is nothing but 1 by 1 minus v square by c square root over into m naught is equal to 1 by 1 minus, here v square is nothing but your, this is nothing but v. Okay, so v square by c square. So c square will be got cancelled. 0.98 square into m naught. Right. You just calculate it. You can found this. It will be 5 m0. Okay. So the option A is the correct answer. Okay. Now we are going to move for the next question. Question number 17. The order and degree of the equation. See, to find the order and degree, we have to search the highest order and its power. In this differential equation, the highest order is d square y by dx square. So order is your 2. Here order is your 2. What will the degree? Degree means the highest order power. So highest order power, if I am going to consider this one, power is your 1. So degree is your 1. So answer will be option C, 2, 1. Now we are going to move next question. Question number 18. The Wronskian for y1 equal to sin 2x, y2 equal to cos 2x is what? In general, Wronskian is represented as this one. Solution 1, 2 and its first derivative y1 dash y2 dash. So here y1 is nothing but sine 2x and cos 2x, and its a derivative sine 2x derivative is nothing but 2 cos 2x. Cos 2x derivative is nothing but minus 2 sine 2x. Okay, so this determinant you just calculate, you can found this determinant will be minus 2, which is not equal to 0. So here the Wronskian, in the question it is asked that what is the Wronskian. The option is B. Suppose this question maybe it will ask that check that this is the dependent or independent. These two solutions are independent or dependent. So here Wronskian not equal to 0. So these two solutions are independent. Okay, independent. You just remember this one. Next question, question number 19. Taylor series expansion of e to the power minus z about point z equal to a equal to 0. That means here z0 equal to 0 given. In general, Taylor series of a function fz is written as what? This one. Summation over z minus z0 to the power n by n factorial into f n z at z equal to z0. Okay, here summation means the addition of terms. So first we have to find out f0. Here n equal to 0 to infinite. So first I am going to consider, we have to calculate f0 z at z equal to z0. So here fz given that e to the power minus z. So e to the power minus z means e to the power 0, it will be 1. Then f dash z at z equal to z0. F dash z, if you are going to calculate, this will be minus e to the power minus z, and at z equal to z0 this value will be minus 1. Next you just find out f double dash z at z equal to z0. Okay, f double dash will be how much? Here single dash is minus e to the minus z, so it will be plus e to the minus z. At z equal to z0 this will be 1. Now consider the summation. Here first term will be z minus z0. Here z0 given 0. First term will be z minus z0 to the power 0. To the power 0 means 1. This factor will be 1 and 0 factorial 1. And f0 z0 which is equal to 1. So this value will be 1. Second term you can found here z minus z0. Here z0 always 0. So z to the power 1 by 1 factorial, z to the power 1 by 1 factorial. Then f dash z equal to z0 which is equal to minus 1. So this will be minus 1. So this will be minus 1. 1 minus z to the power 1 by 1 factorial. Then third term means this one. F double dash z I am going to consider. F double dash z, here z minus z0, that means z to the power 2 by 2 factorial, and this value is your plus 1. So plus 1 and minus 1. So this is the series will be 1 minus z to the power 1 by 1 factorial plus z to the power 2 by 2 factorial and so on. So which option is correct? 1 minus, no, this could not be correct. This one 1 minus z, here 1 factorial is there. 1 minus z plus z to the power 2 by 2 factorial minus z to the 3 by 3 factorial. Okay, 1 plus. So this will be the correct answer. Option B is the correct answer. Now we are going to move next question, question number 20. The volume of the tetrahedron with side, these are three vectors are given. 2i cap plus 3j cap minus 4k cap, I cap plus 2j cap minus k cap, 2i cap plus 3j cap plus 4k cap. Okay, so here you just consider this is the vector A, this is the vector B, this is the vector C. Okay, the tetrahedral structure is like this. This is the typical tetrahedral structure, has 4 faces. This one, that side one face, and this side one face, and this one face. 4 faces. Okay, and its volume of the tetrahedral in general written as 1 by 6. Suppose this is the vector A given in the question, this is the B vector, and this is the C vector. Okay, By considering these three vectors, the volume of this tetrahedron is nothing but 1 by 6 scalar triple product of A, B, C, or we can write 1 by 6 A dot B cross C, A dot B cross C. So first you just calculate B cross C. In your rough you can found the value will be 11 I cap minus 6 j cap minus k cap. Okay, now you just consider A dot B cross C. So here A is the vector. So 2 I cap 11 I cap. This will be 22. 3 j cap minus 6 j cap. It will be minus 18 minus 4 minus k minus 4 k cap minus k. It will be 4. Okay, so we found this value will be 8. So now 8 by 6. If I am going to consider this formula, 8 by 6 is nothing but your 4 by 3. 8 by 6 is nothing but 4 by 3. So this D is your correct option. Okay. Now we are going to go for our next question. Question number 21. It is asked that the unit vector ER cap normal to the surface R equal to constant can be expressed as 4 options are given. Okay, so here the surface equation given that R equal to constant is nothing but a sphere. This is the equation of the sphere whose origin at whose center is at origin. If I am going to consider this one is your z axis, this is your x axis, and this is your y axis. Any arbitrary point P suppose on the surface of this sphere, and this is your position vector r cap, r vector, the position vector from origin, and this is the z component. This is the angle theta with the z axis. Considering the projection on xy plane, this is the phi azimuthal angle, and this is the spherical angle theta. In general, for Cartesian coordinate system, position vector represented as I cap x plus y j cap plus z k cap, right? In case of spherical polar coordinate system, x is nothing but your r cos theta, r sin theta cos phi, r sin theta cos phi, I cap. Y component in spherical polar coordinate system, r sin theta sin phi, j cap, plus z component is your r cos theta, right? R cos theta k cap. Here it is asked that we have to find out the unit normal vector, which is unit normal vector on the surface r equal to constant. That means we have to find out the direction of r, simply direction of r. Okay, so here r is the position vector in spherical polar coordinate system, is represented by this. So what will be its unit vector? Unit vector ER cap is nothing but r vector by r vector magnitude, right? So here r vector is nothing but this one. If I divide r with each term, then ER cap will be sin theta cos phi I cap plus here sin theta sin phi j cap plus cos theta k cap. So this is the value of ER cap, which is perpendicular to this surface, this one. Okay, so which option is correct? Option B is your correct answer. Now we are going to move to our next question, question number 22. In question number 22, it is asked that curl of r vector by rq. R is nothing but your position vector. See, already we know that curl of the position vector is 0. So curl of the position vector multiplied with some constant also will be 0. So this value is a constant. So curl of this value, where r is the position vector, will be 0. The answer will be A. Right. Now we are going to move towards next question. Question number 23. If V is the volume enclosed by the surface, then r cap dot ds will be how much? Okay. For solving this question, you have to remember this formula. First, divergence of r to the power n r vector is equal to n plus 3 into r to the power n, which is most important formula. Always it will be required for different numerical. So I suggest you remember always this formula. It will be useful for other numerical also, and this formula we are going to use for this question. Here you can see in the question it is given that surface integral of this r cap. So here r cap I can write what? R vector by r dot ds. By applying Gauss divergence theorem, it will be the volume integral of divergence of, here this r is the denominator. If I will be taken to numerator, it will be r to the power minus 1 r vector dv. Right. Now consider this one by using this formula. So here volume integration, if I will consider this one by using this, so it will be how much? N, here n is how much? Minus 1 plus 3 into r to the power n. R to the power n means r to the power minus 1 into dv. Okay, is equal to, here this will be how much? Minus 1 plus 3, 2 by r volume integration of dv. So volume integration of dv is nothing but v. So the answer will be 2v by r. So here we found 2v by r. If I will put unit radius is unit 1, then the answer will be equal to 2v. Okay. So for this question number 23, the answer will be 2v. Okay. Now question number 24. X delta dash x is what? This question repeatedly asked 3 years. Past 2 years also it is asked. Okay. So for this one we have to consider nth derivative of delta function. We know nth derivative of delta function in general, delta nx is nothing but minus 1 to the power n by n factorial delta x by x to the power n. This is the general expression of nth derivative of delta function. Right. So here if I will consider n equal to 1, then delta dash x will be equal to minus 1 to the power n, minus 1 to the power 1 itself minus 1 factorial delta x by x. Okay, so that implies x taken this side, so x delta dash x will be equal to minus delta x. So the answer is your C. Consider question number 25. A0, we have to find out A0 in Fourier series expansion of the function, this one 100 by L x in between minus L to L. Okay, very simple. A0 formula that we know, 1 by L minus L to L fx dx. Right. So here you just put 1 by L minus L to L fx, given that 100 by L x dx. Right. So it will be 100 by L square integration minus L to L x dx is equal to 100 by L square, x integration is your x square by 2 minus L to L. Put the limits here and calculate. Here you can see, put the limit L here, L square minus L also L square, so it will be 0. The answer will be 0. Right. Next question. For Laplace solution, the solution of radial part, you have to remember this one, this is the direct question. For Laplace equation, the solution of the radial part are in this format: a r to the power n, b r to the power minus n minus 1. Just remember this one. Next question, we have to find out the integrating factor of this differential equation. This is the linear differential equation, so it can be rewritten as like this: dy by dx plus 2 by x into y equal to x square. So this is in the form of what? dy by dx plus py equal to q, and here p q either function of x or constant, here function of x. So in general, the integrating factor, what we know, integrating factor is nothing but here e to the power integration of p dx. Okay, so e to the power integration of p is nothing but 2 by x dx. So it will be e to the power 2 integration of 1 by x dx. So is equal to e to the power 2 1 by x integration is nothing but ln x, right? Or you can write e to the power ln x square, and you can get the answer is your x square, and option D is the correct answer, right? Now consider next question, question number 28. 28 is given that 15x to the power 3 minus 9x in the term of Legendre polynomial is what? This is very good question, very good question, very good question. Okay, so for that I suggest that you just remember at least 4 Legendre polynomials. 4 Legendre polynomials: p0x is your 1, p1x is your x, p2x equal to 1 by 2 3x square minus 1, p3x, at least 4 you have to remember, very useful, 1 by 2 5x cube minus 3x. Okay, p4x is your 1 by 8 35x to the power 4 minus 30x square plus 3. These 4 I suggest always you have to remember. This type of question you can get in your exam. Okay, so here it is asked that which option is correct. So what is the question given? This one. So take the common 3, so it will be 5x cube minus 3, right? 5x cube minus 3x, sorry, 5x cube minus 3x. Okay, so it can be written in this format, that 6 by 2 5x cube minus 3x itself, it can be written like this, right? Or you can write 6 into 1 by 2 5x cube minus 3x. So here 1 by 2 5x cube minus 3x is nothing but your p3x. So this value will be 6 into p3x. Option A is the correct answer. Okay, next question, Hermite polynomial. Hermite polynomial h2x is how much? This is the direct question. You should remember. Also I suggest at least 3 to 4 Hermite polynomials you have to remember. That is your h0x 1, h1x, very essential. Whenever you are going to solve the linear harmonic oscillators, at that time these Hermite polynomial very much essential. h1x is your 2, h2x is your 4x square minus 2. So obviously a question asked h2x, so this option C is correct answer. And h3x also you have to remember, at least 4, up to h3x is enough, 8x cube minus 12x. So I suggest these 4 and these 4, at least up to p3 you just remember na, for p3 up to p3 itself it is very good for you for your exams. Next question, question number 30, gamma half, we know that root pi, direct question, simple question. Next, beta 1 by 2 equal to how much? This is, here we have to use this formula, beta mn is nothing but gamma m into gamma n by gamma m plus n, right? So here gamma m is nothing but, if I'm going to put here half and half, beta half and half, so here gamma half, gamma 1 by 2 plus 1 by 2 is nothing but gamma 1. So here gamma half is nothing but root pi into root pi by gamma 1 is nothing but 1. So answer will be pi. So option D is your correct answer. Next question number 32. A very important question. I suggest to all of you that you just practice this type of question 1 or 2. But here I am going to give you the general expression and its corresponding answer. Right? Suppose we have a question like this: 0 to 2 pi d theta by a plus b cos theta. So its answer will be 2 pi by a square minus b square to the power 1 by 2. So first of all, I am going to tell to you that this question is asked from your residue problem, type 1 residue, type 1 problem. Okay, but here I am not going to solve this one. I am going to use this formula: 0 to 2 pi d theta by a plus b cos theta or sin theta. Here mistakenly this should be cos theta, right? This should be cos theta, mistakenly written. Okay, so if this type of question will be there, the answer will be 2 pi by a square minus b square root over. For this question, the answer will be 2 pi. Here a is how much? 25 square minus 24 square root over. So this will be 2 pi by 25 square is nothing but 625 minus 24 square 576. You just calculate the denominator, you can find root over of 49. Okay, root over of 49. So 2 pi by 7 is the correct answer. Okay, next question number 33. Laplace transform of equation, this one, ft e to the power 80 minus 1 by a is what? So we have to find out Laplace transform of this equation, this function minus 1 by a, right? So here Laplace transform of this one, what? E to the power 80 by a minus Laplace transform of 1 by a. Okay, Laplace transform, this is the a is the constant taken outside. Laplace transform of e to the power 80 minus 1 by a, Laplace transform of 1. Okay, so here 1 by a, Laplace transform of 80 is nothing but 1 by s minus a minus 1 by a, and Laplace transform of 1 is nothing but 1 by s, right? You just solve this, you can found the answer will be 1 by s into s plus, sorry, s minus s into s minus a. Okay, 1 by, this is the answer, this will be the answer, 1 by s into s minus a. Correct answer is your option A. Next question, the next question is your 34. The first two terms of Lorentz series expansion for fz equal to 1 by z into z minus a for this is the range is given that 0 to 2, z mod greater than 0 less than 2. Okay, so I suggest that you go through my channel and watch the Lorentz series videos. There I solved lots of numericals. You solve those questions, because in future whatever the Lorentz series you are going to found in your exam, easily you can solve. But here I am going to solve this question whatever the method I have been used in my video. Okay, first we have to consider the partial fraction of this function. Function is given that 1 by z into z minus 2. If I consider the partial fraction, then it will be 1 by 2 1 by z minus 1 by z minus 2. Okay, by considering partial fraction we found this one. First we have to find out the Lorentz series of 1 by z, then 1 by z minus 2 separately. First, consider the Lorentz series of 1 by z. Okay. So before that, we have to consider the range. Whatever the range has been given is most important. Here, z mod also can be written as what? Z minus 0 mod. That means center is at 0, and here maximum is 2, up to 2. Okay, if I consider this radius, what? This radius, 2 is the radius, higher value is the 2 radius. So this is the region, uppermost region, but z value is greater than that of the 0. That means we have to consider above 0 and below 2. Okay, now consider this equation. For this equation, here, for this equation, we have to find out the Lorentz series about z equal 0, because its center is at z equal to 0. Okay, for this equation, here 1 by z only is there. So 1 by z, or we can write 1 by z minus 0. That means its center is at z equal to 0. So its Lorentz series 1 by z, and corresponding Lorentz series will be equal to 1 by z itself. Okay, how it is detailed I done in my videos. You can refer those videos. Here it is not possible to discuss all the points. Now consider the LS, Lorentz series of 1 by z minus 2. For this case, this is your z dash is your 2. Okay, z dash is your 2, and z0 always is 0. Here z0 is 0, right? So here z dash means here, that means you are standing over here and you are approaching z0 equal to 0. That means this from outside to inside. So outside to inside approach, for outside to inside approach, see this language, with this language I solved many problems in my videos. You refer that one. This is somewhat different type of language, outside to inside, inside to outside. So any kind of Lorentz series you can easily solve. So here the z dash is your 2 and you are moving from out to in. So out to in formula is nothing but 1 by z dash minus z0 minus z minus z0, right? So for this case, 1 by z dash is how much? 2. 2 minus 0 minus z, z0 is your what? Minus 2. Sorry, z0 is your 0. Okay, so here just compare this equation with the original equation. Original equation is given that 1 by z minus 2. If I consider this one, then this is your 2 minus z. Here, see, if I solve this one into 1 by 2 minus z, it is not equal with my original equation. That means I have to multiply minus 1. Okay, so here, before we have to find out the Lorentz series, we have to consider, is it from out to in or in to out? After that, we have to match, is it matching with the original function? If it is matching, then okay. If it is not matching, then we have to just multiply minus. Okay, now whatever the first term, we have to take the common from this one. So this will be minus 1 by taking common from here 2, this will be 1 minus z by 2. 1 minus z by 2. So this will equal to minus 1 by 2 into 1 by 1 minus z by 2, right? So this is in the form of, this bracket is in the form of 1 by 1 minus x, right? So now finally this series, for this one, what we can write? 1 minus 1 by 2. For this one directly what we have to write? A summation over n equal to 0 to 1, 0 to n, 0 to infinite, and this one z by 2 to the power n. Now the Lorentz series, our Lorentz series, final Lorentz series is this one. We have to consider what? 1 by 2, Lorentz series of 1 by z, we found 1 by z, minus Lorentz series of 1 by z minus 2, we found this one. So this will be minus plus 1 by 2 summation over n equal to 0 to infinity z by 2 to the power n. Okay, see here I done a simple mistake. At the time of partial fraction, this value is your minus, okay, minus of 1 by 2, minus of 1 by 2. See here, if I'll we just subtract these two terms, what we can get, z minus 2 minus z. So minus z plus z got cancelled, minus 2 will come up in the numerator. So only for that we have to divide minus 2. So this will be minus 1 by 2. So here also it will be minus 1 by 2. Minus 1 by 2, 1 by z, like this. So it will be minus 1 by 2, 1 by z plus 1 by 2, and this one if I write in the form of series, it will be, see, j n equals 0 to infinity. So first term will be 1, second term will be z by 2, third term will be z square by 4, and so on. In question it is asked that we have to find out first two terms. First two terms. So here just multiply minus 1 by 2 with this one. This will be minus 1 by minus 1 by 2z, minus 1 by 2z, and this one minus 1 by 2, this is plus 1 by 2. So this will be minus 1 by 2 to the power 2, 2 to the power 2. Then after other terms will come up. So these are the first two terms. So which option is correct? Minus 1 by this one. Option B is the correct answer. Okay. Now we are going to go for our next question. Question number 35. In the question number 35, it is asked that we have to find out e to the power z by z square plus a square at singularities. Most important, very important question. Okay. Very simple question also, but very important question. So what are the singular points for this question? Z square plus a square equal to 0. If I am going to consider z equal to plus or minus ia, the two singular points are z equal to, one is your z equal to ia plus ia and z equal to minus ia. These are the two simple poles itself. So for two simple poles we can use this formula for the residue. For the residues, no, it is as the residues of the, so for the residues we can use the formula as this one, pz by q dash z at z equal to z0. So here pz is nothing but e to the power z, pz is your e to the power z, and qz is your z square plus a square. Therefore q dash z will be equal to 2z. Now the residues, first residue if I am going to calculate, pz is nothing but e to the power z by q dash z, 2z at z0 equal to ia. So first residue will be e to the power ia by 2ia. Likewise second residue will be e to the power minus ia by minus 2ia. What are the two options are correct? This one, option C. Sorry, what is the option here? Option C is the correct answer. Okay. Now the question number 36. The net outward flux of electric field through the closed surface in the form of cylinder is parallel to axis of the cylinder. See here, it is very direct question. Flux मतलब vector and area vector. So this is the cylinder, and here electric field parallel to axis. This is the axis of the cylinder. Electric field is like this only. This is the electric field vector direction, and somewhere, suppose if I am consider this is the area, this area vector is along this way. So what is the angle? Angle is a 90 degree. That means whole area if I am consider, wherever I will consider the area is perpendicular to this E. So E dot ds, suppose this area I am going to consider ds. So here E dot ds will be 0. Okay, so net flux will be 0 for this surface by considering this vector field. So option A is the correct. Very simple question. Next question, at any point r on the perpendicular bisector of the dipole axis, the potential phi due to dipole is what? Four options are given. So as per the question, the dipole means two different polarity charge is separated by a distance. Consider the bisector, perpendicular bisector is this one. Okay, at any point, suppose here we have to find out the potential. From positive charge to this point, the distance, and negative charge to this point distance, both are same. Now potential at point due to the positive charge is nothing but k into q by r. Okay, for negative charge it will be k into minus q by r. So the net potential at this point will be equal to 0. Okay, the option C is the correct. Now we are going to go for our next question, question number 38. It is given that an electron is accelerated from rest through a potential difference V and experiences a force F in a uniform magnetic field entering at right angle to it. Okay, on increasing the potential to V dash, it experiences force 2F in same magnetic field, describing the same path. Then what will the ratio of V dash by V? So as per the question, electron accelerated from rest through a potential difference V. Suppose this is your potential difference. Here this is the potential difference. Okay, potential difference V. This side positive, this side positive. So this is the potential difference V. So electron accelerated in this potential difference along this direction. Suppose this direction is your x direction. Okay, x direction, and magnetic field experiences a force F in a uniform magnetic field entering at right angle to it. To it means to its motion. So along x-axis electron is accelerating, and suppose along y-axis magnetic field is there like this. This is your y-axis and this is your magnetic field. So for potential difference V, this electron experiences a force F. So here as per the Lorentz force, so force, magnetic force is nothing but Q into V cross B, that we know. So here electron is the negative charge, means this will be minus Q into V cross B, or we can write Q into V cross V. V is the velocity. Okay, so here electron moving along x-axis with velocity V, magnetic field present along y direction like this. Initially it was the electron is accelerating in potential difference V. Okay, so the force experienced on the electron having potential V, magnetic force will be equal to how much? Q into B cross B. Here Q into B cross B, or we can write E, charge B cross V. So this is your V direction, this is your B direction. So B cross V means the force will be along this direction, along Z direction. Okay, due to which the electron will tends to move in xy plane in a circular path. Okay, in a circular path, it tends to move in a circular path. So as per the question, when the potential difference V, the force is F. When the potential difference V dash, then force is 2F. So what is the V dash by V? It is asked. So when the potential difference V, then the kinetic energy gained by the electron in this potential difference, it will be kinetic energy gained by electron in V, potential difference V will be how much? This is your E into V, which will be equal to half mass of the electron into velocity of the electron, this much, right? So for this case, V will be how much? Will be 2E potential difference by m root over, right? Now when when potential difference changes to V dash, what will the velocity of the electron? Velocity of the electron, if I am going to write V dash for potential difference V, then it will be 2E V dash by m root over, right? So here we found when the potential difference V, the velocity is your velocity of the electron is this much, 2ev by m root over, when potential difference v dash, then corresponding velocity is your 2ev dash by m, right? Now for potential difference v, what is the force F? What is for the potential difference v dash, what is the force 2F? So consider F by F dash or F by 2F. F by 2F. Automatically we can found the v dash by v. F by 2F. So what is the value of F? F is the magnitude, is your E B into velocity v by E B into v dash, right? Now here F got cancel, that implies 1 by 2, here E got cancel, B got cancel, v by v dash, that implies 1 by 2 equal to, here v equal to how much, 2e v by m root over by v dash is nothing but this one, velocity for v dash potential, 2e v dash by m root over, right? Right. So here you can see that implies here you can see 1 by 2 is equal to, here root 2, everything will be cancelled out, we can get v by v dash root over, that implies v dash by v will be equal to 2 by 1 square or will be equal to 4 by 1. So v dash by v will be equal to 4 by 1. So answer D will be correct. In the answer it is given only 4, or we can write 4:1. So answer D will be correct. Okay. So this is the procedure. Beautiful question. You just practice it. Next question, question number 39. It is asked that the peak value of an alternating EMF alternating EMF equation has been given. E equal to E naught cos omega t. E is 10 volt. Here peak value of EMF alternating EMF given 10 volt. That means E0 given 10 volt. And here frequency given 50 hertz. At time equal to 1 by 600, what is the value? What is the AC value? It is asked. Simple, you have to substitute these values. So here what will be the value of E? E naught given as 10 cos omega is nothing but 2 pi into f into t given as 1 by 600, right? What will the value? So here cos 2 pi, frequency has been given how much, 50, no? 50 into 1 by 600, right? So this will be 10 into cos into, here you can see, here 5 1 0 0 got cancelled, 5 into 2 10 10, so this will be pi by 6, or nothing but cos pi by 6 is nothing but root 3, so root 3 by 2. Okay, cos pi by 6 is nothing but your cos 30 degree, 10 into cos 30 degree, so cos 30 is nothing but root 3 by 2, so 10 into root 3 by 2 is equal to 5 into root 3 is the answer. This option B is your correct answer. Now we are going to go for our next question, question number 40. Very important question. If magnetic flux linked with a stationary loop, suppose this is the loop and magnetic flux coming from a magnet, suppose with the time it is linked, and its equation given like this. First you just study the read the question. If magnetic flux linked with a stationary loop of resistance, this loop having resistance given how much, R, varies with respect to time during the time period as phi. So this is the magnetic flux changes, magnetic flux for a particular time, magnetic flux for a particular time is given like this. So what is the amount of heat generated in the loop during that time t is what? Okay, so here flux at a particular time given this much, resistance given this much, time period is given capital T. So we know that the induced EMF is nothing but your rate of change of magnetic flux. So induced EMF, we have to find out how much heat has been generated. Okay, so first we have to find out the EMF is nothing but minus rate of change of magnetic flux, d phi by dt. So this will be minus d by dt of phi is nothing but given as at into t minus t. So this will be how much? D by dt of, here this will be att minus at square, right? So it will be equal to, EMF will be equal to minus, here this will be at, okay, this will be minus 2at, minus 2at. Okay, okay. Now we know current I through the coil due to this EMF will be how much? V by R. That means induced EMF by the resistance, induced EMF how much? This much value. That means minus a t minus 2at by 2at by R. So this is the instantaneous current flows through this coil when the magnetic flux will change with respect to this coil. Now we have to find out the heating or heating effect. That means how much heat will be produced. So heat is nothing but your I square R into T. Just integrate this much value. So H will be equal to I value here. This is the I value. Okay. So here minus is there, so automatically it will be plus. So integration of 2at minus, first I written this one, minus at whole square by R square into R into dt, right? You just integrate this one. Finally you get the answer. Here R will be one R got cancelled, then integrate with respect to t. Finally you can get the answer, a square by R into t cube by 3. I'm not integrating over here, you just integrate in your rough. So this will be the answer. So what is the option? Option a square by R t cube. So this will be t, matlab here see here instantaneous value we found this much, right? But actually with a time period how much heat will be for a one cycle means this will be 0 to t, integration from 0 to t. So this t will be capital T. You just integrate it, you can found it easily. Okay, so this will be the answer. The option A is the correct one. A square TQ capital TQ by 3R. Okay, okay. Now we are going to go for our next question, question number 41. Del cross B equal to minus del B by del T. Equation is belongs to what? Very easy. You have to remember this one always. This is your Faraday law of electromagnetic induction. Option D. Next question is given that, so here given that E function of k cross r minus vt and magnetic field k cross r minus vt satisfy Maxwell equation, then E magnitude by B magnitude is equal to what? So you just remember always E by B equal to C. This is important expression that you have to remember, or you can found like this. We know that E by H mod is nothing but mu 0 by epsilon 0 root over. Okay, here you can write E by, instead of H you can write B by mu 0 modulus equal to mu 0 by epsilon 0 root over. Okay, so here that implies this will be mu 0 E by B modulus will be equal to mu 0 by epsilon 0 root over. So E by B modulus will be equal to how much? Will be equal to 1 by mu 0 epsilon 0 root over, which is nothing but C. Okay, you just remember this expression always, which is most important. E equal to BC or E by B equal to C. Option correct. B, option B is your correct option. Now we are going to go for our next question, question number 43. For normal incidence, reflection coefficient of the surface is given by. So this is the question from electromagnetic theory, EMT. Okay, this is itself a direct question. You just remember. So reflection coefficient for normal incidence, where theta incident incident angle equal to transmitted angle equal to 0 degree for the normal incident. This is the condition, and for this reflection coefficient R is nothing but n2 minus n1 by n1 plus n2 whole square, or you can write n1 minus n2 by n1 plus n2 whole square. Okay, so which option is the correct? This one, option number A, n1 minus n2 whole square by n1 plus n2 whole square. Okay, okay. So here, if reflection coefficient is this one, then transmitted coefficient, transmission coefficient or coefficient of transmission T, you just remember 4 n1 n2 by n1 plus n2 whole square. Here you can verify this one, R plus T will be equal to 1. That means here n1, that implies n1 minus n2 whole square by n1 plus n2 whole square plus 4 n1 n2 by n1 plus n2 whole square. So this value, the numerator value, so here the denominator is n1 plus n2 whole square and the numerator is also n1 plus n2 whole square. So the value will be 1. Okay, you just remember this one also, transmission coefficient 4 n1 n2 by n1 plus n2 whole square, and this is the reflection coefficient value is this one. Option A is your correct answer. Now we are going to move our next question, question number 44. In the question number 44, it is asked that if a beam of a polarized light has 1/4 of its initial intensity after passing through the analyzer, then the angle between the axis of analyzer and its initial amplitude of the beam is what? A, B, C, D, 4 options, 4 angles are given. This is the question from Malus law. Direct we have to use the Malus law and we can get the answer. According to Malus law, when a light passed through a analyzer, the intensity will be how much? I will be equal to I naught. This is the initial intensity of the light, cos square theta. So here, after passing through the analyzer, the polarized light have the intensity is 1/4 of initial. That means here I will be I naught by 4 equal to I naught cos square theta. So that implies cos square theta will be equal to how much? 1 by 4. That implies cos theta will be equal to 1 by 2. Theta will be equal to how much? Cos inverse 1 by 2 means 60 degree. Okay, cos 60 degree value is your 1 by 2. So option C is the correct. Next question, question number 45. This is the direct question. The thickness of half wave plate for wavelength given, extraordinary refractive index, ordinary refractive index given. This is the direct formula. So thickness T of the half wave plate will be equal to lambda by 2 into modulus of mu e minus mu naught. Okay, you just put all the values, you can get the answer 2.5. Do it in a rough, into 10 to the power minus 3 centimeter. Okay, so which option is correct? Correct is your option D. So here it is asked the half wave plate. If quarter wave plate suppose asked, then what you have to do? For quarter wavelet, the formula is just 4 lambda by 4 into mu e minus mu naught. So for quarter wave plate, the thickness will be T will be equal to lambda by 4 into modulus of mu e minus mu o, refractive index of extraordinary minus refractive index of ordinary ray. Next question, question number 46. If two thin convex lenses having focal length 5 and 4 are coaxial separated by a distance, this one like this. So its focal length is 5 centimeter and this is your 4 centimeter, coaxially separated by a distance 4. It is a very good question and very easy question, even if plus 2 question this one. So what is the equivalent focal length? So equivalent focal length is nothing but 1 by equivalent focal length, I written 1 by capital F will be equal to 1 by f1. This is the general formula. 1 by f2 minus d is the separation distance between the two lenses d by f1 into f2. So 1 by capital F, this is your equivalent focal length, what we intend to find out. 1 by 5 plus 1 by 4 minus distance or separation between the two lenses is your 4 by 5 into 4. 5 into 4, you just solve it, you can found equivalent focal length will be equal to 4 centimeter. You just solve it in your rough. So option B is your correct answer. Now we are going to move to the next question, question number 47. What is the condition for bright and dark fringes for Newton's ring in transmitted and reflected light are reversed? Because see, this is your glass plate, this is your plano convex lens. Okay, plano convex lens. So ray is coming like this, so it is refracted over here, and again it is reflected. So at the time of reflection, so reflected light having the phase difference, so this is the hard surface. Okay, the phase difference will be pi, but when it will transmit through, the phase difference is 0. So here reflected ray has phase difference reversal pi and transmitted ray has no phase reversal. Option D is your correct answer for this question. 47. 48 question, it is given that radius of half period zone of a zone plate having like a convex lens. May you remember this type half period zones, bright dark zones we can found according to Fresnel's concept, Fresnel's law of diffraction. So bright dark half period zones. Okay, like a convex lens of focal length 5 centimeter given, lambda given 5000 angstrom. So what will the radius of first half period zone? So you just remember nth half period zone is equal to n into focal length into lambda root over. So this we need to find out the first one. So it will f into focal length, it is given 5 centimeter, sorry 50 centimeter, 50 into 10 to the power minus 2 centimeter given, so 10 to the minus 2 meter into 5000 into 10 to the power minus 10, because in the form of angstrom given, so 10 to the minus 10. So just solve it, you can found the answer will be equal to 5 into 10 to the minus 2 centimeter. Option C is your correct answer. Question number 49. Question number 49. In the question number 49, it is asked that the product of group velocity and phase velocity of a relativistic particle is what? See, in case of a relativistic particle, the group velocity and phase velocity both are equal. Okay, group velocity equal to phase velocity. And here for relativistic particle, both are equivalent to c. So product of Vg into Vp will be approximately c square. If it is asked that for photon only, so it will be c square directly, but whatever may be the relativistic particle moving with approximate velocity of c. So Vg into Vp for relativistic particle will be equal to c square. The option C is the correct answer. Next question is your question number 50. In the question number 50, it is a very good question, very interesting question. Okay, if a particle of mass 3m is at rest, suppose this is the mass, initially it is at rest, mass is how much? 3m. So what is its momentum, initial momentum for this 3m particle at the rest means it is 0. Now it is decays into two particles, or it is decays or breaked into two particles. So this is suppose m, it is breaked into two particles, one mass m and another mass 2m. So this one moved with velocity suppose v1, and this one moved with velocity v2. So corresponding momentum will be p1 and its corresponding momentum will be p2. Now m1 and 2m with non-zero velocities, so whatever I represented over here, v1 and v2 corresponding p1 and p2 momentums. Then the ratio of de Broglie wavelength of the particles of mass m and 2m is what? De Broglie wavelength in general we know that h by mv, okay, or h by momentum. So for particle 1, this one, suppose this is the particle 1, this is the particle 2. For particle 1, lambda 1 will be h by p1, right, and lambda 2 will be equal to h by p2. Okay, now we are going to use the conservation of momentum. Conservation of momentum is telling that before collision momentum equal to after collision sum of the momentums. So before collision P is 0 equal to 0. So 0 equal to P1 plus P2. So that implies P1 equal to minus P2. Right. So here lambda 1 by lambda 2 if I am going to consider, then H by P1 modulus I just consider H by P2 modulus. So P1 equal to P minus P2 or P1 modulus. So H by P2 is nothing but P1 modulus itself, because here we got P1 equal to minus P2. So both are got cancelled. So this got cancelled. We found the ratio of de Broglie wavelength is nothing but 1:1. That means option B is your correct answer. Now we are going to move towards the next question, question number 51. If difference between nth and n plus 1th Bohr radius of hydrogen atom is equal to its n plus 1 when minus 1th Bohr radius, then value of n is what? 4 options are given. We know that for hydrogen atom, nth radius is proportional to n square, right? N plus 1 radius, n plus 1th radius also proportional to n plus 1 square. Likewise, radius of n minus 1 will be proportional to n minus 1 square, right? As per the question, it has been given that nth, the difference between nth and n plus 1th radius, that means it is given that radius of n plus 1th minus radius of nth is equal to radius of n minus 1th. That implies here is proportional to is there. That means this is nothing but I can write this one equal to some constant n square. Here I can write some constant n plus 1 square. Here I can write k some constant n minus 1 square. I have to just put these values. So instead of r n plus 1, I can write k into n plus 1th square minus rn means k n square minus k into n minus is equal to k into n minus 1 square. That implies k both the side cancelled out. Here we got how much? N square plus 2n plus 1 minus n square is equal to n square plus 1 minus 2n. That implies n square plus 1 got cancelled, 2n moved to LHS side, so it will be 4n will be equal to n square, right? That implies n is equal to 4. So the answer is your option A is the correct answer. Next question, if the mass number of nucleus is A, then the Coulomb energy term EC in Weizsäcker's mass formula is related to A as, this is the direct question, you have to remember this one, this is the direct question. For this question, the answer is your option is proportional to 1 by 3, 1 by a to the power 1 by 3, this one. Option D is the correct answer. Question number 53, half-life radioactive decay is x time its mean life, then what is the x? Half-life T half, we know what? We know 0.693 by lambda. Okay, so here lambda is nothing but your decay constant that we know, right? And average mean lifetime or average lifetime tau is nothing but 1 by lambda, right? So here, or we can write what? Lambda is equal to 1 by tau. Okay, so here if half life of radioactive decay is x time of its mean life, that means here this equation what we can write? T half is equal to, I can write x time of mean lifetime is equal to 0.693 by, here instead of lambda we can write 1 by tau. So that implies here x tau is equal to tau into 0.693. Here tau got cancelled and we found x equal to 0.693. Simple question. Answer is your B. B option is your correct answer. Next question. In question number 54, it is asked that the wave function psi x is given that n into e to the minus x square by 2. Normalization constant n is what? Okay, we have to apply the normalization condition, minus infinity to plus infinity, psi star psi dx equal to 1. This is the normalization condition. So that implies here psi is given this one. Psi star will be itself because there is no imaginary term. So this will be n mod square minus into plus infinity. This into this. That means e to the power minus 2x square by 2. 2 got cancelled. We can find minus e to the x square dx equal to 1. Right. So here this is the even function. We can write n mod square into 2 0 to infinity e to the power minus x square dx equal to 1. According to gamma function, we know 0 to infinity x to the power n e to the minus a x to the power m dx is equal to this formula is very important. You just remember this one. This is very useful in different places. This type of integration. If it is so, this type of integration will be there. Then the value will be 1 by m into 1 by a to the power n plus 1 by m. Okay, gamma n plus 1 by m. So you just compare this integration. So this integration again I am writing here n mod square 2 into 0 to infinity. So here I can write x to the power 0 into e to the power minus x square dx equal to 1. You just compare this integration with this integration. N value is how much? 0, right? M value is how much? Is your 2, and a value is how much? A value is your 1, right? So here n mod square into 2, this integration value will be equal to how much? 1 by m. 1 by m means 1 by 2 into 1 by a to the power. A means 1. So 1 by 1 to the power anything will be equal to 1. Leave it. Gamma n plus 1 by m. N is how much? N is 0. 0 plus 1. That means 1 by m. M value is 2. Is equal to 1. Right? That implies here 2 got cancelled. Gamma half is your root pi. So n mod square into root pi is equal to 1. That implies n will be equal to 1 by pi to the power 1 by 4. So this is the normalization condition. What we intend to find out. Option C is the correct answer. Next question, the expectation value of a px for wave function is this one. For 0 to L. 0 to L. So this is the wave function. This is the familiar wave function. Familiar wave function means for 1D potential box, infinite potential box, this is the wave function. Psi x is equal to 2 by L root over sine pi x by L. That means first energy states. Actually this should be the generalized wave function is your n pi x by L, right? The generalized one is your n pi x by L, but here n is 1 is given. So pi x by L means this is for n is equal to 1. So first wave function, this one. So whatever may be, the particle is moving inside this one dimensional box forward and backward, to and fro motion. So to and fro motion, expectation value of a px along x-axis it is moving. So px means momentum this direction is there, equal magnitude along this direction also is there. So average value of a px equal to 0. Otherwise you can calculate this one by using this one. 0 to L psi star px is nothing but your minus ih cross del by del x psi dx. If you calculate it also, you can get the value 0. The value will be 0. So here option A is your correct answer. This is the familiar question. Next question, question number 56. In 56, it is asked that if 0 point energy of one dimensional harmonic oscillator is this much, then the energy of second excited state. See, for 1D harmonic oscillator, in general, it is written as energy level n plus 1 h cross omega, right? So for 0 point energy, that means for n equal to 0, E0 equal to half n plus 1 by 2. This is n plus 1 by 2 half h cross omega. E1 will be equal to E1 equal to uh, will be equal to 3 by 2 for n equal to 1. If I put n equal to what 1 over here, this will be 3 by 2 h cross omega. E1 3 by 2 h cross omega, right? E2, it is as the second excited state. That means E2 will be equal to, here if I put 2, it will be 5 by 2 h cross omega. So half h cross omega, that means 0 point energy half h cross omega value given as this much. So E2 will be equal to 5 into half h cross omega. So h cross half h cross omega is given this one. So E2 will be equal to 5 into 5.52 into 10 to the minus 27 joule. So the answer will be you just multiply 5 into 5.52, the answer will be this much, 26.25 into 10 to the minus 27 joule. Next question, important question, very important question. Change in kinetic energy, or you can just consider energy due to Larmor precession in case of electron orbiting in magnetic field. Right. So suppose this is your magnetic field. Okay, this is the magnetic dipole, and this is magnetic dipole moment. It is angle is theta, makes an angle theta. So for a particular angle, torque upon this magnetic dipole is nothing but mu cross b or mu b sin theta. So if theta is 90 degree, that means if this will be like this, mu will be like this perpendicular to the magnetic field, then the torque will be maximum. So theta, if pi by 2, if theta equal to pi by 2, then tau is maximum, right? For a particular angle theta, what will the energy possessed by this dipole will be equal to how much? This one, pi by 2 is the reference angle to any angle theta, tau d theta. So this is the force into angular displacement. So this much energy possessed by this dipole, magnetic dipole at this position. So if I integrate it, it will be mu b cos theta, okay, minus mu b cos theta, because here t is nothing but mu b sin theta. Integration of sin theta is equal to minus cos theta. By substituting this upper limit and lower limit, we can found mu b cos theta. So this much energy we can found, or energy possessed by a dipole for a particular angle, right? And mu in electromagnetic field, mu is nothing but I into a, I current and loop. What is the electron? No, electron orbiting. So this is the electron orbiting. So if this is the magnetic dipole moment, so electron is circulating like this. Electron circulating area is like this. Okay, and this magnetic moment precessing about the magnetic field, like this, which is called the Larmor precession, and in that way we can get the Larmor frequency. So here mu equal to Ia. I is nothing but current. Current means Q by T. Q by T means here electron is negative charge, minus E by T. T or frequency, here time period T, into A is your radius pi r square suppose. So 1 by T I can write minus F pi r square, right? So mu equal to this much, and angular momentum of the electron is written as m, velocity of the electron, into r, and v equal to r omega, or v equal to, we can write r into 2 pi into frequency f. So the angular momentum can be written as 2 pi mf into r square, right? If you just put this v value over here, angular momentum we can found this much. So mu value we can write as, by considering this value, and this value, this mu can be written in the form of like this: E by 2m into L. Okay, here if I'll put L value over here, L value 2m got cancelled and we found same answer, minus E f by r square. So mu value we found this one, right? So here change of kinetic energy, it is asked that change of kinetic energy. So the so-called energy, a change of energy or energy stored, this much work done, if I do the this much work done, then that much energy will store by this dipole moment, or that much kinetic energy we can say it will be changed. So how much this value will be? Mu into b. So if theta will be I'm telling about the magnitude, right? So this will be E bl by 2m. Okay, you just put this value over here. So minus minus it will be plus E bl by 2m into cos theta. Okay, so for theta equal to 0 degree, so theta will be equal to 0. So energy, the minimum energy will be EBL by 2m. So change in kinetic energy due to electron orbiting. So this is the minimum energy changed, EBL by 2m. So the answer will be this one, EBL by 2m. The option A will be the correct answer. Next, choose the incorrect answer. 58. Change of entropy in a reversible cycle. A reversible cycle is 0. Incorrect answer. You have to choose the incorrect answer. But this is the correct. Change in entropy in a reversible cycle process is 0. This is correct. Option B, change in entropy in path independent in any thermal. This is also correct. In a reversible process, total entropy of the system and surrounding does not change, but it is changed. It is changed. So this is the incorrect statement. Then entropy can never decrease in any process. This is also correct statement. So this is not incorrect. The correct answer for this question will be the option C. Next question, question number 59. Question number 59 asked that for 1 mole of van der Waals gas, del U by del T at constant T will be equal to dash. So according to van der Waals equation, what we have to write? P plus A by V square into V minus B equal to RT. Equal to RT. So that implies, here you can say P plus A by V square will be equal to RT by V minus B, right? Or that implies P equal to RT by V minus B minus A by V square. So that implies here at constant V, if I'm going to consider at constant V, then this equation, for this equation, del P by del T at constant V will be equal to, see, A is a constant. If V is constant, then this term derivative with respect to T will be equal to 0, and this term the differentiation with respect to T will be equal to T by V minus B. Okay, so here we got del P by del T at constant V equal to R by, sorry, this will R by V minus B, right? And we know from Maxwell's equation, we know what del U by del V at constant T is nothing but your T into del P by del T at constant V minus P. Okay, this relation we know. So del U by del T at constant T, it is asked, will be equal to how much? T into Del P by del T at constant V, we found this much value. You just substitute this value, R by V minus B, right? V minus B minus P value. P value is this much. You just put over here. Okay, minus RT by, this is RT by V minus B. This is minus, so plus A by V square. So this is equal, this is plus RT by V minus B, this is minus RT by V minus B, so both are got cancelled. Finally we found del U by del V at constant T equal to A by V square. So this is the answer, and the correct option is your B. B is your correct option. Okay, next we are going to go for our next question. Most probable speed of the gas in absolute temperature T, uh, absolute temperature T is dash. This is very simple question. This is very simple question. For that, always you have to remember this one, velocity distribution graph. Velocity distribution graph is like this, thermodynamical velocity distribution. So this is the most probable velocity, this is the most probable velocity, velocity of most probable. Then after the velocity of average, mean velocity of average, then velocity of RMS, velocity of RMS. So velocity of RMS is greater than average, average is greater than velocity of most probable velocity. Okay, but most probable velocity means large number of frequencies, means large number of molecule obey or have the most probable velocity if I am going to consider a certain gas container. So most probable velocity contains a large number of particles. Okay, that is separate story. But here you have to remember always what is the equation of most probable speed. So here most probable speed is your what, 2kt by m root over, and this is most probable speed. Most probable is to average is to RMS. Sometimes this question also asked in your exam. Many times it is asked ratio, finding the ratio and different type of question. For average 8 kt by pi m, and for RMS value is your 3 kt by m root over. Okay, so here you can see these 2 m 8 pi, these are the constants. So for most probable, average and RMS, this is proportional with root over of t. So option A is the correct answer. Right, now we are going to go for our next question. Inversion temperature in Joule-Thomson effect in case of van der Waals gas. The option is your 2A by RB. You have to remember. Okay, because van der Waals gas equation is nothing but this one, P plus A by V square into V minus B equal to RT. This is the van der Waals equation. Van der Waals gas equation. That this is the famous gas equation that we know. Okay, from this we can derive del T by del P equal to 1 by Cp into 2A by RT minus B. 2A by RT minus B. Joule-Thomson coefficient for actual gas. So from this expression we can found the condition for heating and condition for cooling. That I am not going to discuss over here. So for this case it is your 2A by RB. Option A is your correct answer. Now we are going to go for our next question. Question number 62. If plane intercepts are 2A, 3B, 3C in a simple cubic unit cell, then Miller indices of a plane. This is a simple question. So here 2A, 3B, 1C is given. That means P is your 2, Q is your 3, R equal to 1. So according to procedure, we have to take the first reciprocal of PQR, 1 by 2, 1 by 3, 1 by 1 is this one. Then we have to simplify by multiplying the LCM of the denominator of these three numbers. So LCM will be the 6. So multiplying with this one 6. So this 6 by 2, 6 by 3 into 6. So here this will 3, 2, 6, 3, 2, 6. So 3, 2, 6 is the Miller indices of this plane. 326. Option D is the correct answer. See, here in the answer it is given that 3 comma 2 comma 6, but actually for the Miller indices no comma will be there. It has to be written in this format. Wrongly it is given in your exam booklet, so no issue, but 3 to 6 numbers are correct. So for this question, 3 to 6 Miller indices is the appropriate Miller indices of the given intercepts. Next, now we are going to move our next question. Question number 63 asks that reciprocal lattice vector of BCC structure are what? See, reciprocal lattice of BCC is nothing but FCC crystal structure and vice versa. That we know. So here I am not going to go for detailed discussion. If you want, you can follow the videos from the playlist, solid state playlist. So here reciprocal lattice vectors of BCC is the FCC, and FCC primitive lattice vectors are in the form of this one. Two components will be there: 2 pi by a I cap j cap, 2 pi by a j cap plus k cap, 2 pi by a k cap plus I cap. So option D is the correct answer. Okay. Likewise, suppose it is asked that reciprocal lattice vector of FCC, suppose asked FCC. So it will be the primitive lattice vector of BCC. So primitive lattice vector of BCC, it is in the form of like this: I cap j cap minus k cap, like this. 2 pi by a, three components will be there. So if FCC will be given, option A will be correct. For this question, option D is the correct answer. Correct option also, you can say. Next question. Question number 64. This is the direct question. Dispersion relation for linear vibration of 1D monoatomic lattice. Direct question. You have to remember this is the dispersion relation. What will be the omega? Omega value will be equal to plus or minus 4 beta by m sin Ka by 2. Option C is the correct answer. Right. Now we are going to move our next question. Epsilon r minus 1 by epsilon r plus 2. This is plus 2. Okay. Epsilon r plus 2 equal to n alpha e by 3, known as for what? This is the famous equation, Clausius-Mosset equation, which relates the macroscopic and microscopic property of a dielectric material. So here dielectric constant epsilon r is nothing but relative permittivity of the material or dielectric constant of the material. Alpha e is the electronic polarizability. So here electronic polarizability is the microscopic property, and relative permittivity of dielectric constant is the macro property. So this relation, Clausius-Mosset relation, giving the relation between macro and micro property of a dielectric material. Next question, question number 66. Transition temperature Tc and critical temperature Sc for superconductor are related. Very famous equation. Should not forget. You should not forget. This is a very important question. This one. Option A is the correct answer. Hc equal to H naught into 1 minus T by Tc whole square, and the graph is like this. This side is your transition temperature, and this side is your applied magnetic field, and the graph is this one. Okay, and this is your Tc. At a Tc, H equal to H0. Here you can see, if I put here T equal to Tc, then Sc equal to H0. Okay, so this is the graph, and this expression you have to remember. You should H0, because by using this this formula, you can solve many numericals itself, numericals for superconductors. So you just remember this one. Next question: interaction between neighbor dipoles is negligible in case of diamagnetic material, antiferromagnetic material, paramagnetic, ferromagnetic. This is the answer is the C. Okay, paramagnetic material, neighbor dipoles interaction is negligible, because see, may you remember, in case of ferromagnetic material, we know that there is a viscous field. Viscous field is nothing but linked between one dipole to another dipole. Okay, they have the link from one dipole to another dipole. Only for that they are aligned. The adjacent dipoles are aligned with each other, and only for that we can get the ferromagnetic material. Antiferromagnetic means dipole moments are opposite with each other, but they have some link. Antiferromagnetic, diamagnetic also like same concept. But in case of paramagnetic materials, there is no interaction between two adjacent dipole moments, they are free to move with applied magnetic field. Okay, so for this question, option C is your correct answer. 68. In Croing-Penny model, the large scattering power of potential suggests for energy band and electron as allowed band and narrower. Allowed band and narrower. Why it is this option? See, in Croing-Penny model, maybe you remember this expression p square sin square alpha a by alpha a plus cos alpha a equal to cos k. Cos k. Croing-Penny model, the large scattering power potential suggests large scattering power. If this is large uh, for energy band and electron charge, allowed bands are narrower. So see, if this p will be large, infinite, then the semiconductor or the material will be act as insulator. Insulator, you just remember, if p tends to 0, then it will act as metal, and if p is finite, then material act as semiconductor. Okay, so here large scattering power means this is the condition has been given the insulator. So for the insulator, see, this is the conduction band, forbidden energy gap, then conduction band, this is the forbidden energy gap. Okay, so if insulator will be there, then conduction band will be narrower. So here which option will be correct? Allowed bands or conduction bands or allowed bands are narrower. So option A will be the correct answer for this question. Option A. Allowed bands are narrow. That means the material act as the insulator for large scattering power, or this p contains the potential, power of a potential. P contains v or potential. Okay, here I am not going to go detail about Croing-Penny model. You can follow the video in my playlist, Croing-Penny model. Okay, next question. At non-zero temperature, Fermi-Dirac distribution function is half when E is what? So you just remember this graph always, most important graph. Okay, so for 0 Kelvin, this graph is for 0 Kelvin, and this is the Fermi-Dirac distribution function. This along x-axis is your E, and this is your EF at EF, and this value is your 1, right? So Fermi-Dirac distribution function at non-zero temperature when energy is what? So this value is half. That means if I increase the temperature, this will be like this. That means electron, this is the your valence band, this side is your conduction band. If I increase the temperature, electron will be moved this side, and corresponding hole will be created in the valence band. And it's a function. So mathematically, what we can write, a Fermi-Dirac distribution function 1 by e to the power e minus ef by kt minus 1, sorry, plus 1. So if e equal to ef, then this value will be equal to how much? E to the power 0 plus 1. That means 1 by e to the 0 is your 1. 1 plus 1 equal to half. That means at ef, e equal to ef, the probability of finding the electron or Fermi-Dirac distribution function will be half. So answer is your E equal to EF. Next question 70. Choose the wrong statement for Bose-Einstein statistics. The first option is your, it holds for indistinguishable particle. Yes, it is correct. Indistinguishable particle. This option is correct. Does not obey Pauli exclusion. This is also correct. Yes, thus this function is 1 by e minus ef by kt plus 1. No, this should be minus 1, because previous question just we discussed for Fermi-Dirac distribution function, this is 1 by 1 minus e minus ef by kt plus 1. So how for Bose-Einstein also same, this it is minus 1. You just remember, most important, this is minus 1. Applies to phonon and photon. This is also correct. So for this question, option C is the correct answer. Question number 71. If Z is a partition function for an ideal gas, then the total internal energy U is, here U is nothing but minus del by del beta of ln Z, del by del beta of ln Z, and beta is nothing but 1 by kBt, 1 by kBt. So that implies what we can do it over here. Del B, if I'm going to calculate, then 1 by kb is the constant, and del of 1 by t here, del of 1 by t. Beta is 1 by kbt, so del beta is nothing but 1 by kb into del of 1 by t will be equal to 1 by kb into 1 minus 1 by t square, right? So therefore u will be equal to how much? So here minus plus 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 del of ln z divided by del b. Del b is nothing but this much, that means 1 by kb into t square. So finally what we can get? Kb into t square, and here I forgot this one, this one del t also is there, del t. So kb into t square del of ln z by del t. So this is the correct answer. So I calculated um, for 1 mole of gas. If one n mole of gas, if I am consider, then n will be multiplied with this answer. So n into kbt square del ln z by del t. So option B is the correct answer. Next question, question number 72. Product of wavelength corresponding to maximum energy lambda t and absolute temperature T is Wien's displacement law. So this is the Wien's displacement law. So this one, Wien's distribution law, no, Wien's placement. Here a printec mistake is there. This should be displacement. In the question paper itself, it is written like this: Wien's placement law. No, Wien's displacement law. So this is the correct answer. Option D is the correct answer. Then question number 73. Ripple factor for a full wave rectifier is how much? Is your full wave rectifier ripple factor is nothing but 0.4. That we know. This is the correct answer. Okay, here I'm going to just recall you. Ripple factor is nothing but I current SC with respect to current TC. It can be evaluated by I RMS square minus I DC square by I DC, root over by I DC, or it can be written as I RMS by I DC square minus 1. Here you can take I DC square common from this square root, so it will be move outside means IDC, so it will be divided by IDC square, this expression. For half wave rectifier, this value will be 1.21. Remember, ripple factor for full wave rectifier it will be 0.482, because this value for full wave rectifier will be how much? Pi by 8 square minus 1 root over will be equal to 0.482. Next question, question number 74. If emitter collector current gain factor is 0.95, then base collector current gain beta is how much? This is very simple and most important expression that you have to remember: 1 minus alpha. So this is beta, base collector current gain. Beta we have to find out. Alpha, emitter collector current gain is given. So that implies beta will be equal to 0.95 by 1 minus 0.95. Value will be equal to 19. Just calculate. Option C is the correct. Next question, question number 75. For Hartley accelerator L1, L2 and MC1 is given. C1, all the options, all the values are given. Then the frequency for Hartley accelerator. Hartley accelerator formula you have to always remember: 1 by 2 pi 1 by L T C root over. Here LT means total inductance. So total inductance LT is nothing but L1 plus L2 plus 2 into mutual inductance 2M. So you just put the value of L1, L2 and 2M, you can found LT value is equal to 36. You just calculate, okay, 36 into 10 to the power minus 3 Henry. C1 given 10 to the power 10 microfarad. This is microfarad. So that means 10 into 10 to the power minus 6. This is mu, mistakenly written mu, okay, microfarad. So 10 to the minus 6. You just put all the values. You can found if just calculate in a rough. You can found that 1 by 2 pi into 10 to the power 4 by 6 Hertz. So which one is the correct answer? Option B is the correct answer. Option B. Next question, the question number 76. The ideal op-amp has, these are the four options. Here I am going to show you the ideal op-amp characteristics. The characteristics of ideal op-amp is your infinite voltage gain. Infinite voltage gain. So infinite voltage gain, finite here, and infinite voltage gain. That means this option is your correct option. Other options we have to just check. Okay. Next, infinite input impedance, zero output impedance. Infinite input impedance, finite input impedance, no, it is not correct. Finite non-zero output impedance, this is the zero output impedance for the ideal op-amp. And finite bandwidth, no, it is not the finite, it is the range of frequency. It is useful for the range of frequency. Range of frequency, you just remember these are the characteristics of ideal op-amp. Okay, these are the characteristics, and this is the basic properties of op-amp itself, you just remember. Next, now go for the next question, question number 77. Addition of two binary numbers. First binary number is this one, 1 1 0 0 1 1 0 0, 1 1 0 0 1 1 0 0. Then second one is your 1 0 0 1 0 1 0, 1 0 0 1 0 1 0. Just simple addition, 0 0 0 0 1 1 1 0 1 1 1. That means it will be 0, carry will be 1, 1 0 1 0 0 0 1 0 1 1 1 0, carry 1. So 1 0 1 0 1 0 double 1 0. Which one? Here you can see 1 0 1 0 1 0 double 1 0. So C option is your correct answer. Now question number 78. It is given that the Lissajous figure is produced by the application of sinusoidal voltages to vertical and horizontal deflecting plates of CRO. The pattern gives 4 tangencies with vertical and 3 tangencies with horizontal. The frequency of a vertical signal for 1 kilohertz horizontal signal is what? It is asked that for vertical signal what is the frequency. So here I am going to show you the 2-3 different Lissajous figures. Here you can see. For this figure, here you can see this is one tangent, this is one tangent. Okay, this is the vertical tangent. Here I can draw one tangent, here also I can draw one tangent. So vertical tangents are 2, horizontal tangents are only 1. Okay, so here vertical tangent is your 2, horizontal tangent is your 1. For this case, vertical tangents are this one, 1 2 3. Okay, 1 2 and 3, but horizontal tangents are only this one. Okay, only this one tangent, or you can draw this one, right? So here 3 vertical tangents and 1 horizontal tangent. For this case, here one tangent, that means at node we can draw one tangent. Here one tangent, here one tangent, here one, here another one. So here 4 vertical tangents and 1 horizontal tangent. For this figure, carefully you observe. For this figure, 3 vertical tangents we can draw, 3 vertical tangents here, 1 1 one tangent, here 2 another tangent, and here 3 another tangent. So 3 vertical tangents, 2 horizontal tangents. 2 horizontal tangents means here 1, here 2. 2 horizontal tangents, 3 is to 2, like. Okay, so for this case, if I'm going to consider vertical tangents, see here one node, here one node, here one node, here, here. So 5 vertical tangents, and these are the 4 horizontal tangents. 4 horizontal tangents. So for this type of numerical, you just remember one formula: frequency of vertical by frequency of horizontal is equal to node of horizontal by node of vertical. So that implies in this question, vertical signal given, frequency of vertical signal asked, given that 1 kilohertz horizontal signal. So we have to find out VFV is nothing but NH by NV into FH. Okay, so FV will be equal to, this is NH. NH means horizontal. Horizontal it is given that 3. 3 vertical nodes are 4 into uh, frequency of horizontal is given 1 kilohertz, that means 1000 hertz. You just solve it, you can get 750 hertz. So answer is B. B option is correct. Next question, Boolean identity A plus ABC plus A B bar C plus A B C bar. If I am going to solve, uh, what will be the correct option? Here you just take common from these two terms AC. We can get B plus BC, B plus B bar plus ABC bar. B plus B bar is nothing but 1. We found AC plus ABC bar. Option C is the correct answer. Next, the decimal system. In the decimal system, the binary number this is what? So this is the fractional binary number. So for this case, what will the answer? This one will be multiplied with 2 into 2 to the power 0. Again this one 1 into 2 to the power 1. Then 0 into 2 to the power 2. Then 1 into 2 to the power 3. Then last one into 2 to the power 4. So first calculate this one. 1 into 2 to the power 4 is 16. Sorry, 16 plus 2 to the power 3, 8. This is 0, this is 2, and this is 1. So this value will be how much? 8 plus 2 is your 10 plus 1, 11, 16, 27. Okay, then fraction part means this one into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 0 into 2 to the power minus 3 plus 1 into 2 to the power minus 4. So this will be equal to 1 by 2 plus 1 by 4 plus 0 plus 1 by 16. You just calculate it, you can find this value will be equal to 0.8125. So which option is correct? See, 27. All options have 27. So D option is correct. D option is correct. So here I am going to suggest that I have a playlist that conversion of numbers. So in that playlist you can find conversion of decimal to binary, binary to decimal, fractional decimal to binary, fractional binary to decimal, decimal to hexadecimal, hexadecimal to binary, means all the conversions you can find here. Go through my channel, you can find one playlist here, conversion of numbers from one system to another. In that playlist you can find these conversions: decimal to binary, binary to decimal, decimal to octal, octal to decimal, and fractional also, fractional decimal to binary, then fractional binary to decimal, fractional decimal to octal, fractional octal to decimal, octal to binary, decimal to hexadecimal, hexadecimal to binary, other different type of conversions, whatever in your digital physics, all I kept over here. You just watch. Okay. So here I completed your 2023 CPET physics question in detail. So here we discussed all the questions, 80 questions, step by step. You just practice it for your exam. Okay. Thank you so much for watching this video. Thank you.